Hello YouTube. Counters are a very important component while designing sequential circuits that can be controlled by a PLC. In this video, we are going to discuss how we can implement a down counter that is going to switch on a lamp, of course, and it is going to count downwards. So for example, if it starts at 5, the circuit is going to be high and it is going to count downwards from 5 to 0. So when it reaches 0, the circuit is de-energized. We are using Tia Portal V17 of Siemens. So right away, let's start by creating a new project. So we are going to call it a down counter and we wait for it to create a new project. Once we have reached in this environment, what we are going to do is to add a new device, which is in most cases a PLC, a controller, that is a CPU, and we are going to use step 7 1200. We look for maybe CPU 15 1215. Then make sure that the version here is above 4, and that is for example 4.2 4.3. So for us the 4.5 is okay. So let's go. Now once we have created our CPU, it's time for us to develop a program block and using ladder logic. So let's come here. We are going to add this. So that is a push button. Then we are going to add a coil here. Then in the middle here, we are going to come to counter operations and select a down counter. Say yes. Then let's go and create PLC tags. These are the tags that we are going to put in these brackets. So we say show all tags, and since they are not there, we just create them. So we have a push button. Then we are also going to create a lamp, and we are going to create a reset. So our lamp should be the output. So you have to remember that the Siemens Tia Portal uses I as the input and Q as the output while addressing your inputs and outputs. So we are set here. Let's go back to our main block. So come here, we look for that tag of a push button. Come here, we look for the one of a lamp. Then we come here and look for the one of reset. So we are going to reset this to, let's take it to 5. And that one, let it remain at 0. So once this circuit is energized, once we push this button, this lamp is going to be on until when the count goes down to 0, then this lamp will go off. So let's right away look at the configuration of our CPU. So come here and we run a simulation so that we can compile all this program into executable file that the CPU can run. So we click on search. After starting a search, we have gotten them, we load, then consider trusted, let it compile the configurations. Okay, so what we are going to do, let's go back to the main body or the main logic diagram. We do the compilation, then okay. So what happens while we are here, we can run. So let's close that and start again. So we go to, so what we are going to do is to go to the general properties and check on security. So we find we still have this protected. Then we go to here and have full control. So these issues are expected if you don't do such settings. So we click on this and we run the simulation so that it can now compile the program. So we say start the search, we load the program onto the CPU, then we let it compile the configuration. So we say load. So when we load, it says start the module. So we are good to go. Let's now click here and we create a simulation table. So let's create a new table once it has opened. a new project. So we call it simulation down counter. We let it create it. So click on sim tables and then click on the sim table one that was created automatically. So let's look for our tags. We needed a push button here. Then we had a lamp and we had a reset button. So our lamp is at address that, the reset is at that. Okay. So let's come to the main and run this. So let's do the monitoring, on off so that we observe that power is reaching here and now the circuit is energized. So let us see what happens with the down counter. So my push button is off. So but what happens when I switch on, it becomes true. Okay, so let me first reset. Yes, so reset your lamp, reset your counter and then start on. So it is at 5, so we are going to go to 4. When you have finished resetting, so go to 4, go to 3, go to 2, you go to 1. So the moment you go to 0, the system is energized. Let's reset again. So this is how we run it. So okay, let's reset. So it is on 4, it's on 3, it's on 2, it's on 1. When it reaches 0, the circuit becomes energized. So ladies and gentlemen, this is how we can design a down counter that can do a number of things as you design your PLC. You want to have sequences, for example, a conveyor belt moving from one end to the other, but every time it reaches somewhere, maybe there is delivery of a particular finished product. So all those complex circuits are designed using counters, and one of them is a down counter, as we have seen how to implement in PLC. Thank you so much.